Today our topic is limits. So in this topic we will learn what is the limit. Okay, it is taken from the 11th class books. So if we assume a function fx equals to x square, we put the limit x tends to 0. So what will we get? Limit x tends to 0 fx equals to x square. So substitute the value. So f0 equals to 0. Meaning of limit is that we are finding out the value nearest to that point. Like here is 0. So just near to that point, something 0.009, and in negative side also minus 0.0016. So we are finding the value at nearest point. Okay. So how will we write it? The function, if we want to find out the value at a limit x tends to a, then limit x tends to a fx equals to L is called the limit of function fx. If x tends to a, if x tends to a, then fx tends to L. So x tends to a, if fx tends to L, then we can write limit x tends to a fx equals to L. This is the value of fx when x tends to a. Now we understand with the example, with one illustration. Hx equals to x square minus 4 upon x minus 2 when x is not equals to 2. Okay. So when x is not equals to 2, when we substitute x equals to 2, what will we get? X equals to 2, in that case it will be 4 minus 4, 0 upon 0. So we will not get value when x equals to 0. So x is not equals to 2. X is not equals to 2. So we can factorize it, x minus 2, x plus 2 upon x minus 2. So x not equals to 2, so what will we get? X minus 2. Hx equals to x plus 2. We can draw it in number line. This is or in the xy coordinate system, x, y equals to x plus 2. So y minus 2 equals to x. This is simple. Y equals to x and shift toward y equals to 2 line. Okay. First we draw y equals to x line. That will be this type. Then we will shift this line towards up. Y equals to 2 here. So minus or hx equals to x. So here point minus 2 comma 0, here point x 0 and y, and x is 0, then what? When x equals to 2, x equals to 2 is somewhere 2. So this curve break, it does not give any value, it is not determined here somewhere. Okay. So when we approach from towards left or right, we are finding the value, but we are not finding the value at that point. We are finding the value from the left side. Yeah, when we tending to from the left side, then that is called left hand limit, LHL. When you are finding the value from right or tending to from right side, then right hand limit. Okay. Or it can simply written limit x tends to a plus, okay, right hand limit, okay, fx. For the left hand limit, x tends to a minus fx. If left hand limit and right hand limit both coincide, okay, so that is the common limit. Then we can say if left hand limit x tends to a plus fx limit x tends to a minus, so both coincide, then it is common limit. We can call it as limit x tends to a fx. Here is one function fx equals to x plus 10. So we want to find out the limit of the function at limit x tends to 5 fx. What is the limit? So for different value of x, here x, fx, so 4.9, 14.9, for different value of x around 5, less than 5 and greater than 5. Okay. 5, 4.59, 14.95, 4.99, then 14.99, 995, 14.995, then 5.001, here 15 point. Okay. When we look toward right side, limit x tends to 5 plus here. So it is tending to 15. Value is tending to approaching to fx value is approaching to 15. So limit x tends to 5 plus fx equals to 15. Here you can see coming from right 5.01, 15.01, 5.00. Then towards from the left hand side at 4.995 limit x tends to 5 minus left hand limit. It is also approaching to 15, 14.995 rounding of 15. So left hand limit and right hand limit are coincides. Okay. Then we can say when limit x tends to 5 plus fx equals to limit x tends to 5 minus fx equal. So limit x tends to 5 equals to 15. When two limits, left hand limit, right hand limit, are not equal, so and there became any break in the function. We can see this through one example. Fx equals to x minus 2 when x less than 0. When x equals to 0, 0, then x plus 2, x 0. Okay. We can draw graph when x greater than 0. Okay. X greater than 0. So here x equals to 0, y equals to x plus 2. Y, first we draw y equals to x, then we shift x towards minus 2. Okay, y equals to x line passes through the origin, and we will shift this either y equals to minus 2, y equals to 2. So this will be this graph. But here this is only the graph when x is greater than 0. So we will take only this portion. Okay. When x is greater than 0. Here is x-axis. Again, when x equals to 0, here is 0. Then x less than 0, graph is y equals to x minus 2. So y equals to x line, this will be, then we shift this line to x equals to 2. Here, graph is somewhere like this. But this is only when x is less than 0. So here. 0 minus 2. Okay. You can see now when x is less than 0, at any point graph is going this side, and x is less than 0, no, x is less than 0, graph is going this side, and x is greater than 0, graph is going. At 0 is 0. Here you can see at x equals to 0, when x equals to 0 or 0. So we will try to find out limit x tends to 0 plus. X tends to 0 plus when x is greater than 0. We get the value from here. X tends to 0 plus, 0 plus we'll get from here. X greater than 0. So substitute here 0 plus 2, that is 2. When x tends to 0 minus, value will be taken from this graph, x minus 2. Okay, 0 minus 2. Left hand limit, right, left hand limit is minus 2, right hand limit is 2. So both limits are not coinciding, and these are not equals to value at 0. So limit does not exist. We can say that limit of the function at 0 does not exist, or we can say this function is not continuous. You will learn this thing later on, that if the limit, left hand limit and right hand limit does not equals to the value of the function, that is discontinuous function. We get the break in the function. Here you can see after 0, positive side going upside, at 0 origin, and less than 0. We will use some theorems. One is limit x tends to a, x raised to power n minus a raised to power n upon x minus a equals to n a raised to power. Okay. So how will we get it? When we divide x raised to n minus e raised to n upon x minus a, what will we get? We will get limit x tends to a, x raised to n minus 1 plus x raised to n minus 2 a, and x raised to n minus 3 a square, and so on, e raised to n. Now you substitute x tends to a everywhere, because if I substitute here you get 0 upon 0 form. What I did, that I divide this by x minus a, and I got this. When x tends to a, substitute a n minus a raised to power n minus 1 plus a raised to n minus 2a. So each term equals to a raised to n minus 1, so it is n times n a raised to n. You will use this expression. Limit x tends to a x raised to n minus a raised to n upon x minus a equals to n a raised to n minus 1. Okay. Okay. That's one example based on it. Limit x tends to 1 x raised to 15 minus 1 upon x raised to 10 minus 1. Here, if I substitute 1 here, 1 minus 1, 1. We can do one thing here. We can divide numerator and denominator both by x minus 1. Okay. Then apply limit x tends to 1. Here is different function, here is different function. Applying limit in numerator part, limit x tends to 1, in this portion we will get 15 x raised to 15 1 raised over 15 minus 1, because here treat as a equals to 1. So 15 into 1 raised to 15. In the lower side or in denominator side, 10 1 raised to over 10 minus 1. This is 1 1, so we get 15 upon 10. That is 3 upon 10. One more problem. Limit x tends to 0, root 1 plus x minus 1 upon x. So we can rationalize it. How we rationalize it? Here plus multiply by, here minus multiply by plus term. So on rationalizing, what will you get? 1 plus x root plus 1 upon root 1 plus x. This is a minus b, this is a plus b. A square minus a square. So 1 plus x minus 1 upon x and root 1 plus x plus 1. Limit x tends to 0. This is x. Limit x tends to 0. X upon x root 1 plus x plus 1. On substitute x in denominator as well as numerator. So cancel out 1 upon and substitute x, then x equals to 0 here. Root 1 plus root 1. That would be 1 by 2. One more theorem that is generally used. Derivation of that I will do later on. Limit, and next in another video, limit x tends to 0 sin x upon x equals to 1. This is also useful. So we will do the problem based on it. Limit x tends to 0 sin ax sin ax upon bx. Okay. We will apply this. Here ax, bx. So what we can do, we can rearrange it. Limit x tends to 0, sin ax upon ax. Okay. Ax upon bx. What am I doing? I am multiplying or dividing by ax. So there will be no change. And here, given sin x upon x, we assume ax as x or capital X somewhere, because when limit x tends to 0, ax also tends to 0. Okay. So this value will be 1, and because x tends to 0, ax tends to 0, we can replace it by x or some any other one. So that is in the form sin y upon y, where limit y tends to 0. Okay. So that will be 1. This will be 1. Ax upon bx. Ax upon bx, x can be cancelled out, then we will get a upon b. If you find any problem related to this topic, you are unable to solve, you can comment. I can make the video on that problem and I will solve that there. Sin limit x tends to 0, sin ax or plus bx upon ax plus sin. Okay. Same thing we did in the previous problem. Sin ax upon ax plus bx. Again ax plus sin bx upon dx multiply by dx. Okay. Why am I doing? We are trying to apply this problem. Sin ax upon ax, that will be 1, and sin bx upon dx, that will also be 1. And here ax, bx. X can be taken out from all sides. What will you get? Limit x tends to 0, sin ax upon ax, a plus b upon a plus sin bx upon bx. Okay, and b here. Limit x tends to 0. This will be 1. This will be 1. What will you get? A plus b upon a plus b. That is equals to 1. I hope you understand this. Now I taught this topic limit and solved some illustrations also. You can do the problems of this chapter. Okay, or ask any problem if you have any doubt, or if you have find any difficulty in that, or you can also write in comment if you want any topic on which I can make the video. One more problem I am doing here. Limit x tends to 0, cos 2x minus 1 upon cos x minus 1. So cos 2x minus 1. We can rearrange it. Limit x tends to 0. 1 minus cos 2x upon 1 minus cos x. We know that 1 minus cos 2x, 2 sine square x, and this is 2 sine x by 2 square. Okay, 2 can be cancelled out. So limit x tends to 0. This can be written sine x upon x whole square. We are dividing by x square and multiplying by x square. In lower term, sine x by 2 upon x by 2 whole square and multiply by x by 2 whole square. This will be, when we apply limit x tends to 0, this will be 1, this will be 1. Okay, here x square will be cancelled out by the x square and the two terms will go up. So we get 4. Okay. If you understand the concept, if you like my video, please subscribe my channel. Thank you.